Let's turn off the lights in this room. Can you see in the dark? While we, humans, cannot see in pitch darkness, some animals can. They have their own unique methods that enable them to move around in the dark. One such animal is the bat, a nocturnal animal that only comes out at night. Contrary to popular belief, bats are not completely blind. In fact, larger bats have a rather good eyesight. However, they have a better way of locating their prey in the dark, and that is through a method called echolocation. Echolocation is the use of sound waves and echoes to determine where objects are in space. This is how it works. First, the bat emits an ultrasound wave, which is a wave at high frequencies that cannot be heard by human ears. The wave propagates outwards into the surroundings. When it hits an object, it is reflected back towards the bat. By sensing and analyzing the returning wave, the bat is able to determine the location of its prey. Besides bats, some whales and dolphins also use echolocation to hunt and navigate. Do you know that scientists study nature for inspiration and ideas to solve common problems faced by humans? This study and emulation of nature is called biomimicry. For example, engineers used the principle of echolocation to create ultrasonic sensors. Ultrasonic sensors are used to tell us how far objects are from us. An ultrasonic sensor consists of two main parts: a transmitter, which sends out signals, and a receiver, which receives the reflected signal. The transmitter emits an ultrasound wave, which upon hitting an object, is reflected back, and detected by the receiver. By calculating how long it takes for the wave to return, the ultrasonic sensor is able to measure the distance. Thus, when using the ultrasonic sensor, make sure that both the transmitter and receiver are exposed, so that the ultrasonic sensor can work effectively. Both infrared and ultrasonic sensors can be used to detect obstacles and measure distances. However, each has its own strengths and shortcomings. In the previous lesson, we learned that infrared sensors cannot be used outdoors, when there's direct sunlight, and that IR sensor readings may vary for different surface colors, although the distance is actually the same. Ultrasonic sensors do not have such problems, as they are not dependent upon the optical reflectivity or color of the object. Thus it is suitable to be used on outdoor robots, or robots operating under bright lights. Besides, Ultrasonic sensors provide long-distance detection, which able to sense object at least up to 200 centimeters. Nevertheless, it has its weaknesses too. As the ultrasonic sensor depends on the reflection of ultrasound waves to measure distance, the object must be able to reflect the waves effectively. A hard surface has no problem doing this. But a soft surface, such as cloth and foam, tends to absorb sound energy. This weakens the reflected wave, and thus the result would be inaccurate. In addition, the size, or area of the object needs to be taken into consideration. The area of the object must be big enough for the ultrasound wave to be reflected back as echoes. Now, let's go straight into using the sensor, and see what we can do with it.